Thanks so much for joining us tonight. My name is Glenn Morangelo, for those of you I haven't met yet, I'm the development director and one of the founders for the Butterfly House. And as we all know, things kind of get a little hectic at this time of year. And they get hectic in very good ways because we're doing a lot of things with friends and family, but it's hectic nonetheless. And that's why I hope that all of you that joined us for Bug Appetit on Halloween, it was this year, will, for the rest of you, you won't know any different, but for those of you who went to Bug Appetit, please forgive me because I'm going to recycle the jokes that I used that night. I just didn't have time to dive in, so. But there are two fresh ones aside from Bug Appetit. Okay. My date with the firefly didn't go so well. There was really no chemistry, just a light attraction. And what makes that joke all the funnier was that my lovely wife, I don't know if she's here, but Jen was dressed up that night as a firefly. And I just didn't put it together that was not the appropriate joke, so I'll apologize again for that. And then this other one's particularly good for the holiday season when many of us are getting together with family. Have you ever noticed how mosquitoes are like family? Yes, they might be annoying, but they carry your blood. All right, that always sets the tone for the evening. So the holiday season is a time where we spend time with friends and family and often give thanks for such a wide variety of things. And at the Butterfly House, we are incredibly thankful for the community enthusiasm that exists for our mission and our facility and our creepy crawlies. We're so thankful to you and so many other folks that make our programs and events like Bugs and Brews successful and a lot of fun. And we're really thankful for the community support that we receive from individuals and businesses. And one of the businesses, as always, I want to give a big shout out to is DraftWorks. Every lecture, they donate all the beer and the hard seltzer. And they've been doing that for a long time and are incredible partners and always want to say thanks. In case you're looking for a great place to hang out with friends and family over the holidays, of course come to the Butterfly House, but there's other things to do at DraftWorks if you haven't been there. I just took a quick look at their calendar and I just want to give a little quick shout out. They've got their annual Christmas steamer coming up on December 12th, which is always a lot of fun. And then they have a wide variety of things depending on the evening that you're going. Things like trivia nights, music bingo, which I'm not sure quite how that works. But they've got a lot of live music on Thursdays, Saturdays, and Sundays. Sunday being a jazz night. And looking at the music that's coming up within the next couple weeks, Andrea Parcell's going to be there, Tom Catmull's going to be there. So they've got some amazing local music that you can enjoy, and I definitely encourage you to check them out. Check out your calendar, and when you go to DraftWorks, please just tell your server how much you appreciate their support of Bugs and Brews and the Butterfly House. And I want to give a shout out, speaking of community partners, to Missoula Community Access Television, better known as MCAT. And over this past year, they've been recording some of our lectures, actually I think all of our lectures this lecture series, and we're thrilled to have them back tonight as part of a media assistance grant donated to the Missoula Butterfly House and Insectarian. If you go to MCAT's YouTube page, you can search for the words Missoula Butterfly, and you will find some of the past lectures that you missed them. You can check them out. Another shout out that I just had to make tonight, we've got always fantastic volunteers. We really appreciate their assistance. But in particular tonight, I just want to shout out to our bartenders, to Tim, Parker, and Cassidy, and for wearing their holiday garb. Yeah, when they walked in, that was perfect. So a few quick things. Yes, I'm the development director, so of course I have to make a quick plug for donations. Year-end is a time of year when many people think about making end-of-year donations to support the various nonprofit organizations that add so much to our lives and to our communities. And thanks to an incredibly generous donor, we've got a 50,000 matching challenge underway that started November 17th and will run to the end of the year. Yesterday was Giving Tuesday, and Giving Tuesday put a nice dent in what we're trying to do. I shouldn't say dent, because that seems negative. It shined it up more. But it gave us a good boost. That's the word I'm looking for. We still have a long ways to go. We're about 45 to 50% of our goal, which is fantastic. We've got about 25,000 to go by the end of the year. If you happen to be one of those people that kind of do your giving at year end, I hope you'll consider the Butterfly House and take advantage of this opportunity to double the impact of your gift. Let's see. I think that's all I really wanted to say. There's always so many things going on, but this is a little bit longer speaker intro because this is a really special speaker this evening. I'll embarrass Scott right off the bat. Our speaker this evening is our very own Dr. Scott Debnam, and among the many buggy hats that he wears, we are incredibly lucky to have him as our live collections assistant. And in particular, in line with his expertise, Scott provides expert care for our honeybee colony. The exhibit actually was a design of his own that we had built. Along with another staff member, Scott designed and watches over the colony of bumblebees that everyone was enjoying. They've been a heck of a lot of fun. And that was a new exhibit that just came on board in May or June, I believe, and is already like a tremendous hit with visitors. It's been a lot of fun. Scott developed a strong fondness for and literally babied our colonies of leafcutter ants, one colony in particular. But so in short, Scott is an incredible wealth of information and an incredible resource for all things Hymenoptera, so bees, ants, and wasps. In regard to Scott's presentation style, and it's nothing short of amazing to witness one of his presentations unfold, and as you'll see tonight, Scott will start with a somewhat basic introduction and overview, but then it is up to you. Your questions essentially drive the rest of the presentation, which always turns out to be incredibly informative and often humorous in its delivery. So if you'd like to see a great presentation tonight, the pressure is on all of you to ask some great questions. So just as running through his CV, Scott is a graduate of the University of Montana Wildlife Biology program and has 25 years of experience managing the University of Montana's research colonies. He completed his master's degree in pollination ecology in 2016 through the University of Montana's Organismal Biology, Ecology, and Evolution program. He received his PhD in insect physiology from the Division of Biological Sciences in 2022. And his research focuses and is focused on nest thermoregulation and the economics associated with thermoregulation. Scott is a Yale Scientific Teaching Fellow with extensive expertise with honeybee ailments and pests. He possesses an intimate knowledge of the insects, and he is eager to pass this on to others. He has been an instructor for the University of Montana Online Master Beekeeping Program for over 10 years, instructing thousands of students from 22 different countries. He is a recipient of the 2019 UPCA Award for Outstanding Online Education, and he began teaching the practical beekeeping online courses for UMass Amherst in 2019, and is delighted to bring his expertise to the University of Massachusetts Sustainable Food and Farming degree program. So essentially, Scott does not sleep. So with that, a warm Buds and Brews welcome for Dr. Scott Debnam.
There we go. Can everybody hear me? I move a lot, so you must be able to hear me using this mic, because that thing will not be able to hold me in place. Yeah, as Glenn said, it's up to us to make this thing a success, because I have nothing prepared. How about that? He just rattled off a paragraph of my accolades. Accolades? And I got nothing prepared. You gonna crochet the whole time? That's cool. She just like, not even looking down, she's making some pair of socks. Anyway, I can talk about this if we want to. I just put this up because it's interesting to me. Anyway, what you're looking at is the brood nest. Everybody knows what brood is? Brood. That's babies, insect babies. That's the brood nest of a honeybee's colony. And honeybees have to heat their brood to 94.5 degrees Celsius on average, okay? So I'm sorry, 34.5 degrees Celsius. That would burn up the world, right? 34.5 degrees Celsius. If you drop a thermostat into any colony anywhere in the world, and they got babies, it's going to read 34.5 degrees Celsius. Any time of year, regardless of ambient temperature, right? So that's what this is showing that. Now, I did find that they keep the various phases of development at different temperatures, but I will not bore you with that. So what you're looking at is a brood nest, right? Everywhere it's bright red, that's where the babies are. Everywhere it is lighter colors, as it gets lighter in color, the cooler the image is, because this is a thermal image. And so even this golden area, that's still in the 80s. Then we get to the 70s and finally, well, probably you need colder than 23 degrees, which is like 72, 74 degrees Fahrenheit. So anyway, they're busy. Now, but the cool thing is, see all those white dots? That's the hottest thing in there. And those white dots are heater bees. Their only job is to heat the brood. So they literally go to a brood cell, look to see who's in it, look to see how old that baby is, and then they provide the appropriate temperature for that baby. See, I told you I move a lot. I'm halfway down the room. So that's what those heater bees are doing. And they can heat. Their thorax is the hottest one now is 38.8. There's one there, there's some there, there's some there, there's some there, there's some there. These are all heater bees. But I have seen them in my research as high as 47 degrees Celsius. That is 115 degrees Fahrenheit. Guess what temperature the proteins start to degrade? 116. Now, it's rare to see 117 degrees Fahrenheit. 115 degrees Fahrenheit heater bee, but I did see more than one. Anyway, there's some biology, and that was fun, right? I'm going to take this down. How this is going to run, I'm going to start answering your questions. If there's some beekeepers in the room, I'll be glad to talk about beekeeping. If the beekeeper asks a beekeeping question, I will give you the background, so who aren't beekeepers, so you'll understand the question, and then I will solve that beekeeper's problem if I can. If I can't, I will hopefully give that beekeeper the biology and ecology so that they can solve that problem themselves. Make sense? The hands are already up. These people have come to my presentations before, and they're going to make my life way easier. Because this thing will bomb if there are no questions. Absolutely bomb.
I'm going to ask, is that a breed of the heater bees?
Oh, she wants to know is the heater bees or a breed. That is a great question.
Are they different than
She stole your question. All right, let's talk about what a bee's life is like. All right, go check this out. When you're a bee and you're born, you will age, right? Unless it's summertime, then you don't age, but we can talk about that later. When you're a bee and you're born, you age. As you age, your job in the colony changes. Okay? Somebody pick a number between 1 and 10.
7.
7. All right, I will use 7 scientific terms in this talk.
10.
After that, we'll just start using layman's terms. Our first scientific term is, are you ready for this? As a bee ages, her job in the colony changes. That is called age polyethism. Can we all say age polyethism?
Age polyethism.
Notice there's an E in that, so it's not age polytheism, meaning they worship more than one God. It's age polyethism. That's just a fancy way of saying as you age, your job changes. Okay, so check this out. I'm a bee. I just emerged. I didn't hatch. It's a pet peeve of mine. I emerged from the cell. Okay? I hatched from an egg. I emerged from my cocoon. Okay? So that means when you look in the chrysallarium, that's what me and Kristen, where's Kristen? Kristen Bowman, there he is. The bee whisperer, the bumblebee, no, the butterfly whisperer. That's what we call the little window that you see the chrysalis of the butterflies. We call it a chrysaliarium. I want that to catch on. We made that word up. So y'all need to start calling it a chrysaliarium. Anyway, butterflies emerge from the chrysalis. They don't hatch. Anyway, when a bee emerges from her cocoon, because bees spin a cocoon also, it's just under a capped cell. And you can see the capped cells right here. There's babies under every one of these capped cells, babies. And they have to metamorphosis, just like a butterfly. Butterflies, bees, wasps, they go through complete metamorphosis. That means when they emerge as an adult, they ain't getting any bigger. There's incomplete metamorphosis. Things like praying mantises do that. When they emerge, they're tiny. Every time they molt, they get bigger and 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 bigger. So that's incomplete metamorphosis. Wasps, butterflies, bumblebees, whoa, my computer went to sleep. All those things have complete metamorphosis. So I'm a bee, I just emerged. So day 1 after emergence, day 2 after emergence. Day 2 after emergence is when I'm going to be a heater bee. Okay? And I can explain why, but it's a long answer. We on board for a long answer? Okay, I'm going to forget the original question. Somebody must commit to remembering the original question. You, sir, can you commit to remembering the original question?
I'll do my best.
I don't know the original question now. Do you?
I believe it was if they were a different species.
Oh, okay. If you can just say, when I forget again, age polytheism, that'll bring me back. You got to bring me back because I'm all over the place. Now, I forgot the second question. Oh, why do 2-day-old, 2 days after emergence, bees, heater bees? All right, check this out. If you are a flying insect, remember it's a long answer. If you are a flying insect, your direct flight muscles, you have 2 huge sets of flight muscles. You have longitudinal flight muscles that go forward and backwards. They connect to your thorax. It's your thorax. Oh, I could draw it. I have a digital whiteboard. Let's draw it. I came prepared. Sorta. Okay. This is the thorax. No, that's no good. It's more like, whoa, it's more like this. It's more like a square. This is the thorax, okay? There are huge flight muscles. Longitudinal run this way. And then there are, let's go with green just because. Then there are dorsal that go this way, okay? Huge. I mean, the thorax is just packed full of muscle. When it comes to insects, the thorax is built for transportation. That's where the wings attach, that's where the legs attach, okay? So remember that. Whenever you look at an insect, wherever their legs go, that's the thorax. I don't care how weird it looks, that is still the thorax. Anyway, 2 huge sets of flight muscles. When you fire, I'm talking loud and I have a microphone. When you fire the dorsal ventral muscles, it pulls the thorax down. Those muscles do not attach to the wings. Isn't that neat? Well, it makes the thorax go from being like this to being like this. That makes the wings go up. All right? When you fire the longitudinal muscles, the red muscles, that makes the thorax go back to its original shape. And that makes the wings go down. Okay? However, there is a special protein in the chitin of the thorax called, second scientific word, elastogen. Can you say elastogen? You will have to say every scientific word. You have to define them before you can leave. There is a quiz.
Lucky you can't remember.
All right, now what is in the word elastogen that we recognize? Elastic, exactly. So this protein is very elastic. So you don't have to fire these muscles a 1-to-1 ratio to get the wings to flap. If you just pull it, the elastogen bounces. So one muscle impulse, muscle fires. Wings beat a lot. Y'all realize this is the flapping, right? So it uses potential energy to make the wings keep flapping. And that's very important because honeybees' wings beat 250 times a second. That is faster than our brains can think. That is faster than their brains can think. So elastogen makes up the difference. Okay? So, in order for elastogen to work, your chitin has to harden. Okay? Now, after a bee emerges, it takes 4 days for her chitin to harden. 4 days. So somewhere around day 2, your muscles are pretty well developed, but your chitin is still soft. So it's cheaper to produce the incredible amount of heat that is necessary to heat the brood. Because if they fire the green muscle and the red muscle asynchronously, we all remember what the word asynchronous means from high school? Wings will flap. If, however, I'm talking loud again, I'm getting excited. If, however, they fire the muscles synchronously, no wing movement, but heat is produced. A tremendous amount of heat is produced. So, 2 days after emergence, your chitin isn't hard, but your muscles are good and strong. It is cheaper to produce that heat. And believe it or not, dadgummit computer. Believe it or not, my PhD thesis was on how much it costs to do this. I thought heating the brood would be as expensive as flight. Flight is tremendously expensive. Just to give you an idea, if you track the metabolic output of an Olympic level sprinter, a gold medal Olympic level sprinter is producing 1% of the metabolic output necessary for insect flight. Insect flight is extremely expensive. So, 2 days after emergence, your muscles are pretty strong, but your chitin is still soft. You're the best person to do that job, best bee to do that job. What was the original question? Bam! Polyage polyethias, there you go. All right, so as you continue to age, I'll just finish the age polyethism so that you have that background knowledge, so if future questions come up, you already know the information. Sound good? This means yes. This means no. And you can just walk out. My feelings will not be hurt. I recognize that this way of presenting is off the charts weird. I get that. I'm a scientist. I'm supposed to show you PowerPoints and slides and graphs. I'm supposed to be a talking head. So I apologize if that's what you expected. My feelings will not be hurt if you leave. 2 days after emergence, you're a heater bee. All right. Somewhere between day 2 and day 8, you are going to eat a lot of protein as a bee. Why? Because you need protein to grow 2 very important glands. Wax gland and a hypopharyngeal gland. Uh-oh, there's our third scientific word. And it's like 6 syllables. All right, you ready? Hypopharyngeal. Hypopharyngeal. Not bad. All right, hypopharyngeal gland will peak in its production 8 days after emergence. And that is the gland that bees use to produce food to feed the babies. Did you get that? Hypopharyngeal gland is the gland that bees use to produce food to feed the babies. Okay? It peaks at 8 days and it atrophies. So, what do you guess they're doing from day 2 to day 8? Feeding the babies. Very good, very good. All right, now somewhere around day 12, the wax glands peak. And then they atrophy somewhere around day 18. So what do you think a bee's doing between day 8 and day 18? Producing wax, right. They're going to, they have to make the cap. Remember that picture of the cap babies? They have to cap those babies. They have to add comb to the colony. They have to, what else you need wax for? That's pretty much all you need wax for. And so that happens between days 12, or day 8 to 18. Now you notice that every job they did was based on what they were best at doing. There's a lesson in there somewhere, right? I used to give talks to the Leadership Council of Missoula every year. They haven't invited me back in a while. I don't know what that's all about. Maybe they didn't like this crazy way of giving presentations. What was I talking about?
Wax.
Wax, thank you. Notice, a bee only does the job she is best suited for physiologically. When she's good at making heat inexpensively, she's a heater bee. When she's good at feeding babies, she feeds babies. When she's good at making wax, she builds and adds to the structure of the hive. Now, once all that stops, you're useless inside the hive. Guess what she does next? Let's go guard the entrance. Because that entire time, while all that other stuff was happening, she was making some venom. She can only make it once in her life, and she has to store it after that. Guess when the venom is most potent? Somewhere between day 14 and day 20. Day 18, she's no longer good at making wax. She goes to the entrance and she becomes a guard bee. All right? She'll get tired of that soon because you're sitting at the door, you're seeing all your friends fly away and come back and they're talking about how big and wonderful the world is. She decides, hey, I want to go check out this big, wonderful world. I'll become a forager bee. She flies out and becomes a forager bee. That's the last job of her life, and she will most likely die out there foraging. Hit by a car, die of old age, wing wear. All flying insects have wing wear, which we can talk about also. If I mention anything along the way, we can make a list of things we can talk about. Did I answer your question?
Yes.
Wait a minute. Someone over here had a question. I'll come back.
I was just wondering if the heater bees exhausted all their energy so they can fly, or can they still fly after that?
That's a great question. They did not exhaust their energy because there are special bees who bring them honey. There are bees whose only job is to bring them honey. So they'll go out of the brood nest and meet another bee, they'll fill them up and they'll go back down. So they're always fueled. But it does not wear them out, if that's what you're asking also. They can still fly. Every bee was probably a heater bee at one point in her life. Every bee fed the babies at one point of her life. Every bee made wax at one point of her life. And every bee was a guard bee at one point of her life. Every bee was a forager at one point in her life. So they all go through this, except for, of course, the queen. Her only job is to make eggs. And the drones, they don't do most of those jobs. Yes, ma'am.
They have wings the whole time.
The whole time. When they emerge from their cell, they have wings. They're fully functional and fully made adult because of complete metamorphosis. Yes, ma'am.
Where are all the baby boy bees?
Where are all the baby boy bees? Like where they are in the hive? All right, I'll just start answering that question with a lot of information. Do the lights keep changing or is it me? Oh, my screen goes to sleep and it makes the white light go away. I'm going to let it stay asleep because I ain't using it. What were we talking about? Drones. All right, check this out. All right, you seen that frame, right? That was on the screen? See, it was a circle, right? Oh, no, don't do that. Dang. All right, someone else needs to take the responsibility of reminding me every 27 minutes, no, every 8 minutes to move my mouse. You want to take that responsibility? What were we talking about? Drones. All right, check it out. You saw the brood frame, remember that? It was a circle of red, right? So that's what a honey frame looks like. Well, that's what a brood frame looks like. It's a circle. So let's say, and I'm calling a frame. Y'all seen, you know that honeybee hives have frames in them, right? We all seen those on TV. Well, what they do is they put the babies in the middle, and they put what we call a honey arc around here. Why? Because you want the nutrients that you need close to it, right? And then they'll store pollen around here. I should have made my baby section bigger because they'll make a big baby section. All right, so that's where they put the workers. Now, I don't want to give drones a bad name. Because I will remind you, no bees would exist without them. That's just how biology works. All right? But they put the drones, and I don't know if this is going to answer your question or not, but they put the drones down here. They put the drones in the peripheral of the brood nest because that is the point at which they are exposed. That's the point that's exposed to the most risk. And the drones are the most expendable. Healthy colonies are the ones that make drones. Weak colonies or small colonies make fewer drones. So they put them in the places that are exposed to the most risk. And they will abandon them first. Let's say you're raising a bunch of babies and a drought occurs. And there's no more pollen coming in. They will abandon the drones first before they start abandoning the workers. And they abandon, if that was to happen, they abandon their babies at the point that has the least investment. So there's eggs, larvae, and pupa. If a drought happens real fast or there's a dearth in resources, they will consume the eggs. Next, they will consume the larva. And then finally, they'll consume the pupa. They consume the ones in order of least investment. By the time you're a pupa, there's a big investment in you, so they might as well let you go ahead and finish. But dearths are kind of rare that are that severe, but when the valley fills with smoke for 2 or 3 weeks, bees don't go as far. They stay close to home, and they will stop making babies altogether. If it's thick enough, if we're standing here and we can't see those mountains, and it's that way for 3 weeks, they'll stop making babies. And then they'll start consuming. They'll do the drones first, and then they consume the workers that have the least amount of investment. Would that answer your question? That's where the drones are, peripheral. There weren't any drones in my research. So I purposely chose that. I was only testing worker bees. Yes, sir?
Can you talk about bees not aging during the summer?
Holy mackerel, you want to talk about bees not aging in the summer? Yeah, see, I can't make no random statements like that and just leave it hanging, Kim. I feel you. All right, check this out. Wouldn't it be great if you could just stop aging? Hey, I'm going to turn that off. All right. This is a big scientific answer, and it will have another scientific word. You okay with that? Yeah. Y'all along for this ride? Yeah. All right, here we go. Let's do this. Let's roll the dice, see what happens, right? Okay. There are 2 very important hormones. Vitalogenin. Yeah, y'all picked up fast. Can we all say vitalogenin? Yes. And juvenile hormone. We have juvenile hormone. All right, so there's vitalogen and there's juvenile hormone. When you emerge as a bee, you have high vitalogenin, low juvenile hormone. Now, there are several cues inside the colony that affect these levels. Okay? So, some of the cues that decrease vitalogenin is pheromone from the larva, decreases vitalogenin. Elevated temperature decreases vitalogen. How hot is it in the brood nest? 34.5 degrees Celsius. That's elevated temperature. Feeding the babies costs you vitalogenin because you got to give them vitalogenin. Got me? All right, and there are other things that increase juvenile hormone. Okay? Queen pheromone actually increases juvenile hormone also. So the longer you're in the hive, well, a laying queen's pheromone. Longer you're in a hive next to her, your juvenile hormone is going to go up. Okay? Believe it or not, there's another pheromone from the larva that increases juvenile hormone. Okay? So when larvae are hungry, that one increases juvenile hormone. When larvae are satiated, that one decreases vitalogenin. All right? So regardless, you don't have to remember all that. Just know that there are pushes and pulls on vitalogenin and juvenile hormone. So as you age, you lose vitalogenin and you gain juvenile hormone. Boom. So a forager looks like, I just emerged, I look like this, high vitalogen, low juvenile hormone. Forager looks like this, high juvenile hormone, no vitalogenin. Okay? Now, in the wintertime, bees don't make babies. So that means there is no larval pheromones, there's not a laying queen, and there is no elevated temperature inside the nest. Juvenile hormone vitalogen stays way up here, juvenile hormone stays way down here. When that happens, you don't age. Spring rolls around, and they cannot age. The longest one on record not aging is 315 days. That's almost a year. They can suspend aging for almost a year. On average, it's 200 days, but that totally depends on where you are in the world. If you live somewhere in the world that produces pollen, they'll start making babies. That's the trigger to make babies. We need pollen to make babies because pollen is a protein source and babies need protein to grow. So once the outside world starts making pollen, boom, all those other factors kick into place and we start switching again. But in the winter, they're suspended in the nurse bee phase, which is perfect, right? Because the very first thing you need to do in the spring is start making a lot of babies? Great question. Thanks. Let's go with Misty in the back. She's a fellow employee.
What do they do when it's hotter than their ideal temperature?
That's a great question, Misty. Misty wants to know what they do when it's warmer than 34.5 degrees Celsius. Doesn't happen much here in Montana, so let that sink in for a minute. I don't care how hot you think it is outside, it's too cold for a honeybee or a honeybee baby. 90% of the time, honeybees in Montana have to heat the brood. However, I'm from Alabama. I don't know if you noticed. I say words like oil and spoiled. So y'all don't laugh because you don't know what those words are. I don't know how y'all say it, but this is what I'm saying. Oil. Oil. What is wrong with you northern people? Spoiled is when a kid gets everything given to him. Spoiled. What were we talking about? Oh. All right, so in Montana, 90% of the time, they have to heat the brood. In Alabama, where I'm from, that's not the case. There will be days, it could be a string of days, where it's too hot. All right, so I'm a bee. It's my job to keep the brood nest 34.5 degrees Celsius. But you notice that I'm a heat source. You know, not all the bees were white, but every one of them that entered the brood nest was red, right? So I'm a thermal mass. So the very first thing that I can do if it gets too hot is leave. And it's called bearding. It looks like a beard on front of the hive. A beard of bees. So they all just go outside and they sit there. I'm a thermal mass. I ain't helping this matter, so I'm going to go sit outside. All right, the second thing they do if that doesn't work, Miss Misty, is they'll start to fan. They will literally blow air out the front. So they actively blow out hot air, and then they stop and let cool air passively come in.
Out of their mouths?
Nope, wings. Wings. Good question. How are we supposed to know? Yeah. They fan with their wings. So they'll brace themselves and they'll stick their butt up real high, and they'll flap their wings. But they flap in a pattern that does not generate lift. They flap up and down. Now, I don't know how many cartoons you've seen and bees fly like this. That is not how bees fly. Bees fly in a figure 8. That generates lift. This does not generate lift. I heard something. All right, so they start fanning. So they blow hot air out actively and they passively let cold air come in. If that doesn't work, they do something amazing. They fly out and get water, bring it back to the nest, regurgitate that water onto the wax, and evaporate it off. It's called evaporative cooling, and that works because water has a high specific heat. That means water can absorb lots of heat, and then they blow that humid air out the front. And I've been in, I've been in Sandia Labs. That's where the atomic bomb was tested. I've been there doing research on honeybees, and it was 112 degrees. It was 114 on one of the days. And they're so good at evaporative cooling, and I ain't even making this up. I should have took a picture. But I stuck my hand in, and water droplets appeared all over my hand. That's how good they are. But to do that, every bee stopped foraging for anything except water. We know this because we were providing them sugar water at target locations. When it hit 112, and we would have thousands at these sugar water feeding stations. When the temperature hit 112 Fahrenheit, 0 bees, and they all were flying to the water. But they can cool a substantial amount. Great question, Miss Misty. Thanks. Let's go with this lady right here. She's filming me, and that makes me feel self-conscious. Well, you can't film me. University of Montana says you can't film me unless you have my permission.
May I film you?
Yes.
So I met a friend in Belize when I was working in a research station out there. He has a small passion fruit farm. Right now, he has to do all of his pollination
By hand.
He's wondering how he can attract bumblebees or carpenter bees to be able to do that stuff. I mean, almost carpenter, right?
For
Okay, she asked, she has a friend who has a farm and bees aren't visiting his passion fruit. All right, so the reason bees aren't visiting it, or pollinators aren't visiting it, is because it either lacks carbohydrates or it lacks protein. So this either doesn't produce enough nectar in its flowers or doesn't produce enough protein in its flowers. Now, mankind has screwed the pooch on this. I did some research on melons a few years ago, 15 years ago, right? Same question. A melon farmer came and said, hey man, I keep paying for these honeybees. I keep renting these honeybees for pollination, but none of them are visiting my melons. So, we put a net over 100 yards of melons. We put a colony in there and we watched. And sure enough, not interested. And they had nothing else to go for. And so then we sampled the melons' nectar output and pollen output. And the nectar output was almost zero. Why? What do you want your melon to be? And? Starts with a J. Juicy. So if you have bred a melon to be juicy, it must take that water from someplace else. Nectar is sugar and water. So I would suspect, I don't know, I'm not there, that there's something wrong with passion fruit is no longer interesting to pollinators for some reason. All right? I don't know what that reason is. Now, you can get more pollinators in and amongst the orchard if you put blanket flowers down. Other flowers grow in the rows. Just grow other things in the rows. Whatever grows in his area. And that will draw in other pollinators. There's a lot of research to support that. And it'll draw in the diversity of pollinators. Bumblebees, leafcutter bees, all kinds. But that's still, so there'll be more in the area, so they may visit the passion fruit. But unless the passion fruit is giving them something worth their effort, they're not going to do it. Honeybees especially. Honeybees are real picky. Honeybees are smart. They weigh things like how far I got to fly, how sweet is the nectar, how much can I carry, how fast can I... Viscosity even plays a role. If it's too thick and they can't pull it through their proboscis is a straw. And if it's too thick and they can't pull it in, they won't even do it then. So there's a lot of variables in play. But he should start by checking out the passion fruit, see what it's lacking. And then try blanket flowers to see if he can draw in pollinators. Because humans are terrible pollinators. There's a mountain of evidence to support that. Hand pollinating with a Q-tip, we are not good at it. I'm sorry. All right. We'll go here and we'll bounce over there.
I just want to revisit the thermal regulation for a second.
We can revisit it all day long. That's my thing.
So how do they know, like, do they have some kind of internal thermostat or something? How do they know, okay, we need to leave and go get beer right now, or we need to go get water right now? How do they, does someone order that? Do they know internally?
That's a great question. She asked, in case everybody hadn't heard, basically wants to know how bees know what temperature it is so they know what to do, right? Yeah. I started this whole thing by saying they look into the cell, figure out the age of the bee, and decide what temperature it needs to be. So that must mean they can determine temperature and determine when it gets too hot. They have special receivers on their antenna that detect heat. That was an easy answer. Well, let's bounce over here and then we'll bounce over there.
So in your profession, have you noticed any difference between domesticated beehives and wild beehives?
That is a great question. She wants to know if there's a difference between domesticated and wild bees. First of all, we need to define our terms. I'm a scientist. Scientists always start by defining terms, which really pisses people off when they try to make small talk with me. They're like, well, let's define our terms. Is that true? First of all, is it even true what you said? So we'll define our terms. Now, here's the fun thing. The very first tenet of domestication is, anybody? Can't survive without humans. Look at this guy. He must have domesticated something. Your wife? Not. Or she domesticated you and you're like, yeah, man, I know. I can't survive without her, man. That's beautiful, by the way. Y'all might be brother and sister. I don't know. What were we talking about? How are we going to start talking about your relationship status?
Wild bees.
Domestication, wild bees. There we go. All right, so I'm going to posit, as a scientist, that there aren't any domesticated bees. Because, check it out, we put them in a box, right? That box has a door, right? They can come and go as they please, right? They can leave any time. And if they do leave, they do just fine out in the world. so they can survive without man. So I don't use words like domestication and I don't use domesticated and feral. I use managed bees and naturally nesting bees. There is no difference between managed bees and naturally nesting bees. Man has tried to breed certain bees, but what's the first tenet of breeding? Anybody? No. Reproductive isolation. And because of the random mating pattern of Hymenopterans, there is no reproductive isolation. So there aren't any breeds either. Well, there's very few, maybe some in Europe in the mountainous regions, but a honeybee queen, a virgin honeybee queen can fly 4 miles on average to mate. She can go as far as 7. So you got to make sure there's no other breeds within that a 7-mile circle. Man, that's hundreds of square miles. And it's just not realistic in the United States. So there aren't any breeds. So no, there's no difference between managed colonies and naturally nesting colonies. And there are more naturally nesting colonies than there are managed colonies in most areas of the world. And there are more managed colonies on planet Earth today than ever before. Do not give your money to anyone saying save the bees. If they say that, make them define their terms. What do you mean by bee? If they say honeybee, say don't give them a single dime. If they say native bee, say which one, where, because there are local extinctions, not global extinctions. Okay? Make them define their terms. Well, I got serious there, didn't I? Wasn't there? Oh yeah, this lady. I got to get this lady. No, this lady behind you. We'll come back. Because you're saving me when no one else has a question.
Okay, so you were talking about how they use honey for their extreme metabolic output.
Yeah. Well, they use nectar.
Is there similarities to how humans metabolize honey or nectar to how bees metabolize it and use it for energy output?
It correlates very closely. It's just metabolizing sugar. And both bees and humans have the enzyme to metabolize sucrose, which most nectar is sucrose. So keep in mind, sugars are the easiest energy source, right? They're easiest. Even though sugar and protein have the same calories per gram, right? 4. Sugar's easier to access metabolically speaking. So that's why these flying insects use nectar. It's out there, it's available, it's readily, and it's easy to access. And in fact, one of my slides, I teach pollination classes all over the place. One of my slides does say, why do plants give nectar? And that's the answer. Good question, thanks. All right, we'll go with this gentleman way in the back.
Who are the enemies of the bee?
Who is the enemies of the bee? Well, there is a clade of birds in Africa, not America, that are called bee eaters. They eat bees. Not just honeybees, but any bee. They're not immune to the venom, but they capture bees by the thorax and then beat them to death by slamming them against rocks. It's vicious. And when they slam the abdomen side, they crush the venom out of the abdomen, then they eat the bee. There are parasites, of course. Everything in nature has parasites. You know what the number one killer of wild animals is? Parasites. There are funguses. You know what the number one decomposer in the world is? Fungus. Fungus is everywhere. If we stopped moving right now, a fungus would grow on you. Because there are billions of spores in this room right now. So bee-eating birds, there are funguses, there are parasites, there are mites that attack bees. So there are quite a few bee enemies. But bees got a pretty good way of taking care of all of those things. They grew up, lack of a better word, amongst them. It's just that managed bees, managed bees are kept because you want a product, usually, right? So if you want a product, you want to increase the workforce. And so to increase the workforce, you make the hive bigger. All right, let's define our terms. I am a scientist. In this lecture, and I don't care what you do when you leave, but in this lecture, we need to realize hive and colony are not interchangeable. A hive is the wax, is the cavity they're living in. If you're a managed colony, it's the box. A colony are the bees and the babies. Okay? So if you are a managed bee, your owner wants you to produce a product. That product could be wax, could be honey, could be pollination services. Either way, they want to grow the colony to a very large size. You do that by making the hive bigger and bigger and bigger, because the colony will fill whatever space you give them if they can. So what you've done is you've increased the size of the brood nest 5 times bigger than it should be. Guess where most of these parasites, pathogens attack? The brood nest. So you make an overly large brood nest, you've increased the likelihood of these diseases getting out of control or out of balance, I like to say. Because remember, these parasites do not benefit if they kill the host. But they can't help but grow if you give them enough room. Now, naturally nesting colonies live in a very small box, about 40 liters volume. That's about this big. Managed colonies are 5 times bigger than that. So the biggest enemy of honeybees is the beekeeper. But how do you think we can afford to feed 8 billion people on planet Earth? Innovations in agriculture. Guess what one of the biggest innovations in agriculture is? Pollination services provided by honeybees. So you got to do what you got to do. Because some of you are too young to realize that 30 years ago, there were 4 billion people on planet Earth, and every scientist was saying, there's no way this planet can support 6 billion people. Now we're at 8 billion. Why? Because of innovations in agriculture. 1 acre can feed so many more people now than it could 50, 60, 100 years ago. Yes, ma'am, so you saved me. No one else has a question.
How do you find a queen? If you want to start a...
Okay.
How do you find a queen?
You can't just run around and find a queen, right? That's not how honeybees do it. You can do that with bumblebees. You can just find a bumblebee queen. In the spring, every bumblebee you see is a queen because they have a different overwintering strategy. And we can talk about the overwintering strategy after I answer your question. But if you want to start beekeeping, you have to buy a full colony. So you can buy a package. That's what it's called. It's a box with 3 pounds of bees and a queen. Or you can buy a split. That's where a colony got so big, they started making queens and they pulled that part out. Or you can capture a swarm. That's when a swarm is when a colony gets so big, and this happens in the spring for honeybees. Honeybees reproduce at a colony level in the spring. They'll fly and they'll ball up on a tree limb, and you can capture that. So that's some ways to start beekeeping. If you want to know how queens are reared, that's a big, long answer, but I'll give it to you because that's what I'm here for. But let's answer this young man's question first.
What do bees use pollen and honey for? How do they make honey?
He wants to know what bees use pollen and honey for and how they make honey. All right, pollen is a protein source. So it's used to feed the babies. That's it. They feed the babies the protein. And remember, between 2 and 8 days after emergence, an adult bee will eat pollen to encourage the growth of these glands that they need, which we've already discussed. So that's what the protein is for. Gland development, raising babies, which is extremely important, right? Because honeybees, one of the biggest, was very big colony. That's why they're good for agriculture. The honey is used to survive the winter. They don't make honey for your coffee. They make honey so they can survive the winter. A honeybee colony will overwinter as a fully functional colony. They reduce the size. The colony you see in the Insectarian is 2 frames. It was 5 frames in the summer. Okay? But they reduce the size so they have fewer mouths to feed. And then they just shiver to generate heat using these flight muscles we talked about. And they eat the honey to fuel that. How they make honey? Well, they make it from nectar. They visit flowers. Flowers produce nectar, trying to convince remember, because the flower needs the bee for reproduction. Flower needs the bee to take pollen to another flower of the same species. So the flowers actually offer nectar, sugar and water. So the bees take that, take it back to the hive. You want the long answer or the short answer?
Long.
We got all night, right? Y'all ain't got to be no. I have no idea when this thing's supposed to be over. I'll just keep talking. Long answer. Okay, check it out. I'm going to need help from the audience. You want to help me? Sure. Will you stand right here? You want to help me? Sure. Will you stand right here next to this man? I should pick only women because only women do this. Your question, you got to help me. You stand right next to her. You want to help me? Sure. You stand next to her? Him? Okay. Now, here we go. I'm a bee. I flew out to this flower. I get me a whole bunch of pollen. Nectar, sorry. Oh, this is empty. Not a good flower. I will visit another one. But I would have known if I was a bee. We can talk about how if y'all want to know. All right, so I'm going to get me some nectar. I'm going to fly back to the hive. I'm going to come into the hive. I'm a forager. I am not going to deposit my nectar in the cell. The cells are the little things. Y'all saw those in the observation hive? They do everything in those cells. This guy's going to find me. I'm going to give my pollen nectar to him. Her. We all got to be girls here. In the process of exchanging our food through trophallaxis, our fifth scientific term, trophallaxis. Very good. That is where one animal feeds another animal. Through the process of trophallaxis, it starts to evaporate the water off of it. Okay, because remember, it's nectar, it's sugar in water. It's mostly sugar, it's mostly water. It's between 10 and 70% sugar. Bees like between 30 and 60% sugar. So let's say it's a 50% sugar solution. I'm going to feed this guy. He's going to take my load. I'm going to go back to foraging because I'm free now. My load is done. But I fed myself on the nectar. Okay? I didn't just get extra nectar to bring back. I fed myself and got extra nectar, and I gave it to this guy. While we exchanged it, it evaporated some of the water. He feeds off my nectar, gives it to her. She did this exchange, more evaporation, but she gets fed. She turns and gives it to him, etc., etc. He gets fed, but he puts it in the cell. Y'all can all be seated. Thank you very much. I appreciate that. Round of applause. But wait, there's more. We are not done. All right? Now we've finally made it to the cell. We fed everybody, right? That means no one had to eat the honey we already made. Isn't that clever? No one's eating our reserve honey. We fed everybody. And some made it to the cell. And every time it was exchanged, enzymes were added. Now it's finally in the cell. We'll spend all night long evaporating the rest of the water off. If we don't have enough enzymes in there, because sometimes instead of 4 bees, it's only 2 bees. We had 4 bees in our example. Sometimes it's only 2 bees, depending how busy, depending on how much nectar is coming in. If lots of nectar is coming in, there's fewer bees in the chain. Okay? If a little bit of nectar is coming in, there's more bees in the chain. So once it gets us, if there's not enough enzymes when it's in the cell, we'll suck it up, spit it out, suck it up, spit it out, suck it up, spit it out, adding enzymes every time while other bees are evaporating the water off. That's how honey is made. Honey is a precious commodity, you people. Don't let a drop fall on the counter. That's a bee's life's work. And you just wipe it away like, oh well. How wasteful. I am so disappointed. Don't ever do that. I got to go in the back, but I'll come back to you because you saved me when no one else has a question. Yes?
How do queen bees decide on where to create like a hive?
Oh, that's cute. She thinks the queen makes decisions. A queen is important for colony cohesion, but she ain't the boss. You ain't the boss of me. Okay, check it out. All right. Remember I told you a swarm is when a colony divides into 2, right? So we got one colony. They get too big for the nest, for the hive. See, we know our terms now, don't we? One colony gets too big for the hive. That's what triggers swarming, colony level reproduction. Half of them leave, boom, fly out into the world, taking the old mother with them. Virgin mother stays. But we ain't worried about they're gone. We fly out into the world, but we ain't got nowhere to go. So we're going to land somewhere safe. On a tree, on a fence post, on a tractor tongue. Tractor tongue is the thing you put the ball on to drag stuff around. And we're going to make a big old ball of bees. That is controlled by the queen's pheromone. She's the boss of that. Wherever she lands, everyone's going to come to. All right, they're going to stay there for about 2 days on average. So if someone calls me and says, I got a swarm, the very first question I will ask, how long has it been there? If they say 2 days, I say it'll be gone tomorrow. If they say it just landed, I say on my way, 'cause that's a free colony. So we got a ball of bees on a tree. The queen controlled that. They're going to stay there for 2 days. What are they doing for 2 days? Scouting. They're looking for a new home. So they send out a whole bunch of scouts. Now what I'm about to tell you is going to seem unbelievable, but it's true. All right? Okay. I'm deciding if I need to illustrate or not. I'm going to illustrate because what the heck. So we got our ball of bees. We got red scout, blue scout, purple scout, green scout. They have all found a location that they like. Now, scout bees are looking for several criteria. Okay? The cavity needs to be at least 40 liters. But no bigger than 50 liters. And they measure it by walking and flying it. Yeah, thank you very much for being amazed. I'm amazed. They measure it by walking and flying. So they measure width and depth. They want a small entrance at the bottom. If there are more than one entrance, they're not concerned about that. They'll fix that later. They want a small entrance at the bottom. They need to be weather tight. Because remember, they're going to store all their food and babies in this bad boy, so it's got to be weather, and they got to survive the winter in this thing. So those are just some of the criteria. They need to be high off the ground. There's a lot of criteria, but I don't want to make this thing too long. So those are the criteria they're looking for. Okay? Now, our red scout, she flies back. And remember, it's a ball of bees. And she will do a waggle dance advertising her location. Now, let's say her location is 25 liters, has a single lower entrance and well sealed. That's 2 out of 3. 2 out of 3 ain't bad. She will advertise that. She will dance for 3 minutes. I'm making these numbers up just to make it easy. She'll dance for 3 minutes advertising that location. So she'll attract 3 minutes worth of foragers, scouts. Okay? So our green, she came back. Our blue came back. And our purple came back. Remember, this is not even an unbelievable part. Whoa, don't update. Not now of all time. They're all doing the same thing, advertising their location. Look at Putin. I bet he's a beekeeper. They're all advertising their location. Okay? So let's say the green, so red was 2 out of 3. Let's say green is 3 out of 3. Let's say blue is 1 out of 3. And purple is 2 out of 3. Okay. So red is going to dance for 3 minutes, as we all have already established. She's going to dance for 3 minutes because she's excited about hers. And green's going to dance for 4 minutes. 1 out of 3 is going to dance for 1 minute. 2 out of 3, we already know is 3 minutes. So the longer you dance, the more. Keep in mind that red, green, blue, and purple no longer return to their location. They pick another location to scout for. So our red one came back. Let's say she interprets blue. She will fly to blue and check it out, come back and advertise it for 1 minute because it's no good. Okay? Eventually, that one's going to fall off. Oops. That's a bad eraser. No one cares anymore about this one. Everyone is still checking out everything else. All right? Eventually, this one's going to fall off. because you're not dancing long enough, because you're not excited about it, because you know it's not good. Okay? Everybody is still checking everyone else's site out and coming back and advertising for it. Eventually, this one's going to fall off. And then, this is the part that's unbelievable. At one point, every scout is advertising the same location. That is the point at which, when they reach a consensus, yeah, this is democracy in this bad boy. When they reach a consensus, the entire swarm lifts off and flies in that direction, led by the scouts who have all already visited it. That's how they find a new home. Great question. See, that was an in-depth question. She must have a degree in some kind of biology. Well, if you don't, you should consider it, young lady. Yeah.
Did you ever check the temperature in the swarm before they decided where they were going to locate? Because aren't they sitting at a cooler temperature, and then when they all decide to go, the temperature rises for flight?
That's a great question. She asked if the temperature, I've never looked at the temperature of a swarm because that work was done in the 70s by Heinrich to great detail. And nothing else I could add to it. And you're right. Heinrich found in the 70s and early 80s that half the weight of a swarm is the honey they store in their stomachs. So when a swarm leaves, they take honey from the source colony because they need to fuel all this voting we just discussed. Remember, flight's expensive. So they bring their own food source along with them. Oh, Mr. Glenn's here. We've got to finish this thing up. Two more questions, says Mr. Glenn. All right, so when they come back, man, that thing flew by, Mr. Glenn. This was fun. Y'all had a good time? I had a good time. So half the weight is the swarm. They do keep the mantle around 50 degrees and the core around 70 degrees, which is the same for an overwintering colony, by the way. And they can only last about 6 days on their stored honey. And then they got abandoned ship. That answer your question? Two more questions. Got to be somebody who never asked one. This guy never asked one.
So you talk about nectar and pollen, but do they have a source for fat?
Don't need it. Do not have a source for. You ask they have a source for fat, they don't need it.
Do they build up fat in their bodies?
Nope. See that, but that's a bad thing, right? Why do we store fat? Future energy. Oops. If you're a bee, you can't store fat. Most insects can't store fat. Few can, but most can't. That means if you run out of food, you die.
Is it longest in
You have to keep getting food.
Migrants can hold fat?
Yeah, some of them can, yeah. Like well, not to the level that we can. So why can't insects store fat? They're locked inside of a...
Oh, they're hard outside.
Exactly. They're locked in... We can store fat because we'll just keep getting bigger and bigger and bigger. That is... What if I was wearing a suit of armor? And what? I can't keep getting bigger and bigger and bigger. So, but the benefits of the exoskeleton outweigh the fact that they can't get food, which is why. So, if you must acquire food, right? Because you can store very little. They can't store little, but they must acquire food. That explains why there aren't any insects right now. They didn't store any. They can't. So they must find another way to survive that frozen wasteland that you call Montana. Remember, I'm from Alabama. I was shocked my first winter here. I'm shocked still. One more question. There's somebody over here who never asked a question. Yes, ma'am. He's the bad guy. He's ending this thing, not me.
Where does the queen come from in the first place?
Where does a queen come from in the first place? That's a great question. Any worker could be a queen. Any worker could be a queen. Queens are made based on the environment in which they are raised. Okay? So, let's say a colony loses, I'll try to make this fast, Mr. Glenn. Colony loses a queen. They will choose 6 or 8 day-old larvae. It has to be day-old larvae. Older than that, they make subpar queens. So they'll pick day-old larvae, start immediately feeding them a special food, and they'll feed them that special food their entire lives. So not only do they get a special food, they get more food, and they get that special food their entire lives. And then they will also modify the size of the cell. Because remember, honeybee babies grow up in a cell, so they'll modify the size of the cell to accommodate the larger queen and the excess food. That's how they make queens. Does that answer your question? Fantastic. I had a really good time with y'all. Thank you so much. I'll see y'all next time.
I think you'll all agree it's amazing how the presentation just unfolds, and Scott's enthusiasm is just incredible. So again, thanks, Scott. So this would be when we normally open up the Q&A section, but we did that about an hour ago. So thank you all so much for coming. Have a wonderful holiday season. Bugs and Brews in the future. January 27th is the next one. It's going to be an inside peek at a butterfly farm in Costa Rica that a group of us visited in October. So we're going to give you the kind of behind the scenes and a little bit of some other cool Costa Rican stuff. And I believe February, and Misty might be able to correct me, but I think it's going to be on insect sex, pretty much. So right around Valentine's Day, so it'll be very appropriate. And then we're still lining out some speakers for March, April, and May, but it should be great when we pick things back up in January. So have a wonderful holiday season, and we'll see you soon.